All right, let's start again. That was fun. Okay, so we got a 5-kilogram bomb. It's at rest, and it explodes into 3 pieces, each of which travels parallel to the ground. So what that does is it creates a 2-dimensional situation. Obviously, when a bomb goes kablooey, it's moving in 3 dimensions, right? But that's going to be way too hard to do. How would you break that into components, by the way, if we had 3 dimensions? Like you've got your X and your Y. You would have a Z or Z component that you would, basically it would work exactly the same. It would just, you'd have to deal with that Z component. And your whole direction thing would be like,
What would the next direction be?
well, it would have to be like 40 degrees east of south and then also forward, or there'd be some sort of, yeah. You'd have to have some convention to deal with that. We won't be seeing that, but. Okay, so anyways, the first piece with a mass of 1.2 kilograms travels at 5 meters per second, 5.5 at an angle of 20 south of east. The second is 2.5 kilograms, travels at 4.1 at an angle of 25 north of east. Determine the velocity of the third piece. So we are looking for, I guess, V3, right? You'll notice, Josh, it does not give you the mass of the third piece. You should be able to figure that out, right? So the mass of the third piece is going to be 5 minus 1.2 minus 2.5, right? That you should be able to do. I'm going nuts today. I'm going to go without notes.
Again?
Did I do that yesterday? I know. I'll have to channel the spirit of Arpad Mataban because we're doing 2D, we're doing modern geometry here. 1.3 kilos. How do we start all of these? Is Dawson talking about me?
Dawson?
Oh, he's making fun of you.
I just said what a guy is full of them. Jokes, gosh. Oh, sorry.
Remind me to tell you a Mendelssohn story when I'm done.
What?
Professor Mendelssohn. Just write that down. Professor Mendelssohn. It'll remind me. I got another good one. Okay. So again, Pi is equal to Pf. Now what is the initial momentum? 0. Oh, well, that makes things a whole lot easier, doesn't it? Okay. Do we want to do this by vector subtraction?
Does it depend on how it's set up?
Well, I mean, right now is where.
So much clearer.
So we can do vector addition in the other option? Is that what you're
Yeah, I mean, it's.
saying?
You know what? Okay, let me. I mean, right away I know how to do it by vector subtraction, but now I'm trying to think about how to do it by any other sort of set. I think we will. So that's going to be P1 plus P2 plus P3. Now, do we need to include our prime stuff? You could, because prime means after the explosion. We have something happening after the explosion. But because we don't have anything happening before, we don't really have to distinguish between one and the other, right? So it would just clutter things up. We could do it if we wanted, but it's not really necessary in this case. Does that make sense? Yeah? Okay. So we know P1, we know P2. We are solving for P3, right? We need to find vector P3, momentum of P3, and then we're going to divide by the mass to get the velocity. So P3 is 0 minus P1 minus P2, right? Is it vector subtraction? I guess it is. It's 0 subtract those vectors, which is real easy because you don't even have to subtract anything. It's just 0 minus that, right? Does that make sense? Kind of? I mean, I guess you could say that P1 plus P2 equals P3, right? That makes sense. It's kind of like the equilibrium kind of thing, right? Like if P1 is like this and P2 is like that, they would have to add up to give you the third one, right? I can't separate those, but doesn't that make sense? Right? It'd have to be the sum of those, right? You could look at it that way too. It's all kind of how you want to look at it. Let's do it this way. But regardless, we need to break that into components. So let's go P1, and let's figure out, I'm going to do it a little bit different today. Let's figure out what P1 equals. P1 is equal to 1.2 times 5.5, right? Mass times velocity. M1V1. 1.2 times 5.5. 1.2 times 5.5. 6.6 kilogram meters per second. Yesterday I didn't do that, I just put it all as part of the component thing. And I realized after I probably should have done it. 1.2 times 5.5, right Josh?
No, P1 equals M.
M1V1.
Two past 3 for 1/3.
It's just a
We're dealing with piece 1, that's all, right?
Yeah.
You probably should. So that's going to be 6.6 at 20 south of east. Remember doing that? South of east. So south of east. East first and then south. 20 south of east. And this is going to be 6.6. So this is going to be P1x and that's going to be P1y, right? And we break it into those components. So P1x, the x is adjacent to the 20. So 6.6 times the cosine of 20. $6.2. And that's to the right. So it's going to be positive. And I wanted a bit more room there. How much room did you guys leave yourselves to the right?
I don't know which one. Maybe we could-
P1y would be 6.6 sine 20. 2.26. Well, I guess if we're going one decimal place, 2.3. And that's down though, isn't it? Right? So negative. Take your time, make sure that those directions are right. Now we're going to do exactly the same thing with P2. Is this any different than yesterday?
No.
Like all that's really, in fact, these are actually easier because the initial is 0, right? These are actually easier. Unless, of course, the bomb is already moving.
The only thing is, are you going to vector
You're not
subtracted or
gonna
vector
do it for
added because
I think there's one like that. Say
Are you going to subtract it or are you going to add it?
We'll get to that, yeah. We'll get to that.
the
Okay.
bomb. Okay.
We'll get to that.
Okay.
I know what you're worried about. But we're getting a little bit ahead of ourselves. P2. Okay, so P2 is M2V2. I sure wish, it's too bad there wasn't a formula that had R and D in it, eh?
Yeah.
It's too bad there wasn't a formula that had R and D in it. Well, then it'd be R2D2.
Have you seen the movie yet?
I have not seen the movie, no spoilers.
I bet you the good guy wins.
Spoil it.
Did you go last night? Mass of the second piece is 2.5 and 4.1.
No, because I'm not giving you that reference.
Does not attend class regularly.
Yes. Are you going today? No. 10.3. And that's at 25 north of east. 25 north of east. North of east. East. 25. North of east. See how I repeat myself here? I'm trying to make sure I get it right. 10.3. This is P2X, P2Y.
Happy about it, Megan.
P2X. X is adjacent. 10.3. Cosine. 25. 9.3, and that is to the right, so positive. P2y is equal to 10.3 sine 25, opposite, 10.3 times 4.4, and that's to the up, so that's positive 2, 4.4. Okay. I'm going to be honest with you. When I mark these, I literally look to the bottom of the page. If the answer's right, and I quickly scan, yeah, all steps all look right, check. Say that's it, or whatever it is. It's so much easier to get it right. Please do that.
Okay.
So just get it right.
You can do that.
So every
Is that it?
Then if it's not right, then I start going backwards. I usually check here. The most common mistake is you get your sign and your cos backwards.
Yep.
Or you miss a drop a negative and then everything all goes,
To heck.
yes.
That's what I'm gonna do.
Gee, thanks,
I'm
Johnny.
calling it right now. I'm not gonna do that, right?
Okay, now Megan asked, how are we going to do this, right? So we said P3 is equal to 0 minus P1 minus P2. So in other words, P3x, I'll put it in red, P3x is 0 minus, let's just do P1x minus P2x, right? Okay then, yeah. So 0 minus, now P1x was 6.2, double check the direction, it's right. 6.2. P3x is also to the right, so minus 9.3. Does that work for you, Megan?
Sort
Do it like that?
I don't like it.
You don't like it? Really?
It's just weird. That's all.
You can't subtract from 0? Is that what's bothering you?
Well, I don't know. I just like having negatives attached to something as either a negative something or a subtraction.
Oh.
Weird.
Well, okay.
So maybe it's just negative 6.
Well, then think of it as a subtract. Like that if you want.
Yeah.
Does that help?
Yes.
So for Megan, we'll put those blues in. If you don't like those, then just ignore it.
Is that it?
That's the x, so what do you have to do? Let me put it down over here. I want to put these side by side. I know you can't do that, right?
I can't.
So I'm going to do the same thing for my y's, right? P3y is going to be 0 minus P1y minus P2y. P1y, now that's minus 2.3, right? So be careful. So it's subtract minus 2.3, and then subtract 4.4. Now we got to be a little careful here, right? That's subtract a negative 2.3, so that's 2.3 positive 2.3 minus 4.14 minus 2.1. Okay. Good, Tara?
You're okay, Nathan?
Yeah.
Is that it?
Are we done?
No.
No, we're not. Now we got to take those components in, put them back together. You always got to put them back together. We've done this a lot.
I like it. Let's do it.
P3x, so it's left and down, which is what we expected, right?
Sure, that's exactly right.
Well,
Sure.
if this bomb piece is going up to the right, and this one's going down to the left, the other one's going to have to go to the left at some point, right?
Yeah.
And most of it is going up, 10.3, so that means that the majority is going to have to be going down over here. 2.1, right? So that's going to be P3. So now I would write P3 squared, 15.5 squared plus 2.1 squared, 15.5 squared plus 2.1 squared equals square root 15.6. That seems reasonable. Kilogram meters per second. Two last steps, what are they? Convert back to velocity and find the angle.
Oh, right.
Like which order you do those in? No. No, of course not. They're they're not unrelated, but one doesn't depend on the other, right? That's what I'm trying to say. So P, I guess technically P3 is equal to M3V3. So 15.6. The mass of the third piece we did figure out to be way at the top. Oh my goodness, 1.3. Does that kind of match the speeds of the other ones?
Not necessarily.
Well, one was 10.3 and the other was, oh no, that's not true. The other speeds were, 4.1 and 5.5, but this one is, it's lighter, it's 1.3, right? 9.6?
Well, shouldn't it be the exact opposite? Oh no, I guess because of the
Yes, direction. So that's going to be 2.1, 15.5. We'll say 8 degrees. So that's going to be west, 8 south. That's it. So remember, I'll tell you now. Remember, that's why you kept asking. Remember that the day before the test, I'll tell you which one of the three you need to know. I will randomly select either 2D explosion or a 2D collision elastic or a 2D collision inelastic.
You should take the explosion.
And then I'll let the computer do it, and the night before I'll say this is what it is. But you have to be prepared to do all three. It's just that there's only going to be one on the test, because otherwise it takes forever. 20 minutes.
They're all the same.
They're really not a whole lot different than each other. You're right.
So then another 9 mark.
Something like that, yeah. That's right. Is it what? Yeah. 1, 2, 3. Probably 4 or 5 there, I guess, depending. 6. Certainly 7 marks. 8 right there, right? Yeah. So 8 or 9. That's a nice freebie, don't you think?
Big explosions and explosions.
Yeah. I would agree. Yeah. All marks aren't created equal, I guess. Okay, so Professor Mendelson. Should I leave it on for Tally to listen to at home? Professor Mendelson he was an older professor. This was 1987. Okay? And I remember going home like the first month, and my dad asking me, who your professors were. He said, well, there might have been some that I had when I was there. I'm like, I doubted that, but anyway. So yeah, and he says, Mendelson, he was old when I was there. So Professor Mendelson was probably 80 something when I had it, in the 80s. Yes. He was, I think, yeah, I think he was a distinguished professor, which means like he's sort of like well known. He's got a reputation. He's written a bunch of books and that. He probably only taught one class, right? So he was teaching me honors calculus because I decided that I want to take honors calculus. Stupid.
What does that mean, honors calculus?
It meant back then that first year calculus you take the first half credit, and then you write an exam, and then you do the second half. And it's 2 separate courses, right? So you write an exam and it's like they're separate. So because I was taking honors, I had to do the whole. It was the 2 courses put together, and it was a little bit more advanced. Stupid. So, anyways, Professor Mendelson was teaching honors calculus. So I wasn't worried about 20 minutes in the room. And he comes in one day, and remember, you know how we got those boards that you can slide back and forth?
Yeah.
Okay, so it's like that, but a blackboard, right? So he starts writing, and he's pretty old because he's deaf, right? And so on board number 1, he makes a mistake. And we all see it. He's like, dropped a negative, or I don't even remember what it was, but he made a mistake. And we're trying to get his attention, but he's so involved in the problems, and he's not hearing very good that he doesn't hear us, right? So he keeps going. So after about 5 minutes, we just gave up. Closed our book, because we knew that it was wrong. Right? Yeah. And he's just beginning, right? Sliding boards, and just going. Spends like 45 minutes, gets to right to the end, and goes, that's not right. I must have made a mistake somewhere. We'll do it again tomorrow, he says.
Oh my god.
That's
So
not.
that was your class, just watching.
Watching him, yeah, I don't know why we didn't walk out, I guess we're resting
Well, why
pretty
don't you
late.
go up to him and be like, yo, that
I don't know.
Yeah, I would.
He was in the state, he didn't,
Respect.
yeah, exactly.
didn't mess with
One time, in McRae Hall, there's like 6 floors, and all of the floors, you get off the elevator, and they're all like laid out exactly the same, right? So if you don't look at the doors, like if you just sort of went in blindfolded, you wouldn't know what floor you're on. They're all exactly the same. But all the doors have numbers on them, right? Like floor 2 starts with 2, and then floor 3, and so on, right? So the room right above us was exactly the same. So he walked in there once. There was a couple people studying. He started teaching.
No way.
Yeah, seriously, started teaching. We sat in the room downstairs waiting for him. We waited like 10, 15 minutes, finally left. He tells us the next class what happened. He went into the wrong room, couldn't find us. Didn't know where we were.
Imagine if you just started in that room. You just, what is?
What's he doing?
He's just allowed to do.
There are more. Oh, there it is right there. So page 312, numbers 85 to 94 are all 2-dimensional. And I don't know which ones are explosions. Number 90 is an explosion. So is number 94. Looks like 88 is also explosion, so there's at least 3 like that.
Okay.
Okay?
So that's on page 312.
Yeah.
Yeah, really.
You want me to? You guys have your books, right? Do you want me to go run those off? Like you don't need them today, right?
Yeah, no, we don't need it.
Okay.
We'll be okay.
You got it. Okay, good. Let's go back to what's on the test. Let's go back to the outcomes, right? So, problem types. Calculate momentum using P equals M times V. Well, those are super easy, right?
Right.
Impulse momentum, fat math problems. So, you should be able to do 1D collisions, inelastic, and elastic, and explosions. So, there's 3 types there. And 2D collisions, inelastic, elastic, and explosions. So, there's 3 types there. Right? So do enough.
In one of those.
There's only going to be one of those on the test. I just haven't told you which one.
It's only two practical.
Impulse momentum equation? What is that?
No. That's just F equals MA. A is equal to delta V over delta T, which is where you get F delta T is equal to M delta T.
And then that determines the impulse area, that's that like triangle, rectangle.
Yeah. Under a graph, right?
And then
We did that. Right? That was that thing you handed out online thing?
so do we have to do that on this test?
Nope.